Alright, so for my problem, I'll be doing problem number 1 on the 2013 AP, and it's with a calculator. Alright, so I'm going to start off the video with story time, but before that, we've got a Hungarian word of the day, which is story. It's a cognate. Yay! Now, our story is, we got Mr. Deram here, and he runs a gravel processing plant on the side. And we know that gravel goes into the plant at this function g, which is 90 plus 45 cosine of t squared over 18, and it goes out of the processing plant just at 100 tons per hour. And we also know that Deram's workday is going to be an 8-hour workday from 0 to 8, because those are times. So the first thing that the question asks us is to find g prime of 5. And so this is real easy peasy. We just take the derivative of this function here. The 90 goes away, and we end up with negative 45 sine of t squared over 18 times t over 9, because chain rule, yeah, and get the happy circle to find cosine to negative sine. Okay, so if you plug 5 into this function here, you end up getting some number. You end up getting negative 24. 0.5875. Right. And this is tons per hour.
Switching between German and English really rapidly, and my English was like really accented.
Okay. So we know that g prime of 5 is the rate that gravel is decreasing. The rate that gravel is decreasing by this much. So like. So since this is g prime instead of g, this is the rate that gravel is decreasing is actually itself decreasing by 24.5875 tons per hour. Cool. The next part of the question asks for the total gravel put in during the workday. So for that, we're going to set up an integral from 0 to 8 of the function g. And that goes to 8 of 90 plus 45 cosine t squared over 18. And you can plug that into your calculator by pressing the math button, and then 9, and plugging it in like Deram taught us. If you do that, you'll get 825.551. That's a better 5. And for the part C, it wants us to find whether g is increasing or decreasing at time t equals 5. So to do this, we're going to use both of these functions that we started with. To start off, we're going to just plug in 5 to g of t. And if you plug that into your calculator, you get this number here, 98.1408, and then the gravel out at t equals 5 is just going to be 100 tons, because it's constant. And so we know that 98 is less than 100, so gravel out will be greater than gravel in for here. And then for the last part of the problem, it asks for the point, or it asks for the max amount of gravel that's ever going to be in Deram's processing plant. And so for that, we're going to create a new function, which is going to be the function of just total gravel in the machine. Let's just call it z of t. And this is going to be g of t minus 100, and that'll get net rate. But we also have to take into account that we're adding 500 for the start, and since we want to find all the gravel in here, we'll take an integral of this bit from 0 to 8. And to find the critical points of this, we'll take the derivative. So we want to find when we want to find z prime of t. So taking the integral of this, this will just go back to g of t minus 100, and 500 goes away. And the integral goes away because we're taking the derivative of the integral. Hooray, that makes it simpler. And to find when this equals 0, we'll just do normal algebra related stuff. And so then we end up with 100 equals 90 plus 45 cosine t squared over 18. And we can simplify that and then plug it in the calculator just to save some time in this video. And we find that t equals 4.9325. And for this value, we're going to use this as a critical point along with the start and end values. So let's set up a table. And put our values in it. So here we have z of t, and here we have the values we're using for t. We're going to use 0 because it's the start, and then the value we found earlier of the 4.9235, and then we're going to use the 8 because it's the end. And if we plug these back into the function z that we found earlier, you get 500 for the start, 635.
Also, you should tell me what else is there. I don't actually know.
376 here, and for the end you get 525.555. And here we see that this is the maximum amount of gravel because it's the largest number. So 635 tons of gravel is the max amount of gravel that's in the plant throughout the entire workday. Yay, now you know more calculus.
Woo, go Leo.